Hello and welcome back to Ganesh Institute channel. So in today's video we are going to discuss about units and measurements, that means dimensions and their uses. So let's begin with some of the concepts. Let's say what do you mean by dimension? We usually say that the speed of an object is 5 meter per second. This is meter per second. Or if something, an object weighs 60 grams or 60 kilograms, right? So all these units, these are units of a physical quantity which is mass, right? This is for velocity or speed, whichever it is, if direction is given. So whenever you talk about a physical quantity, there are units. Some are fundamental and some are derived. So what do you mean by both of these? Fundamental means basic. These are 7 quantities like mass, length, time, amount of a substance, temperature, and current and luminous intensity. So if you talk about the units for these, so mass can be measured in kgs, meter for length, second for time, amount of substance is in mole, temperature in Kelvin, current in ampere, and luminous intensity in candela form. Okay, so these are the units. Now, it is not exclusively kilogram, gram is also there, right? So for unit system, we have 3 types of unit system with us. One is MKS, another one is CGS, and the last one is FPS. When your mass, length, and time are in this format, mass in kgs, MKS we are talking about. So mass in kgs, length in meter, and time in second. Then this is MKS system, and this is called SI unit. That means Standard International Units, and it is applicable everywhere. Whereas CGS is when mass is in gram, length is in centimeter, and time is in second. Similarly, for this is international system. So mass is in pound, length is in foot, and time is in second. Time is same. So this is the unit system. You always denote in the form of dimension. In parentheses, you take this as M, L, T. So these are the 7 fundamental physical quantities. Sorry, 4, 5, 6, 7. Now, if you talk about derived, so derived means which have been extracted from fundamental. Let's say if I'm talking about speed. So you know the formula of speed. Speed is distance traveled by an object per unit time, right? So for distance you have unit as meter, and for time you have in second if you are talking about MKS. So it would be meter per second. But obviously there will be no existence of meter per second without meter and second. That means without distance and time. So that means derived units are dependent on fundamental, and they are derived. They are extracted from fundamental, right? So this is how it works. Let's say if you want to change it into dimension form, a dimensional formula, then it would be, this is mass. Sorry, this is meter. That means the unit of length. So L. This is second. That means time. So L by T, or you can say LT minus 1. This would be the dimension. And in standard form, you always put MLT format. So M is not here. So m raised to power 0, L1, t minus 1 would be the dimension for speed, right? I hope you understand this, the concept of fundamental and derived. Sometimes it may be asked that what do you mean by, if let's say a question is given to you and you need to find out the values inside it. So for that you need to understand some of the topics that for dimensions you never consider constant terms, okay? Like if you have energy, So if I ask what is the dimensional formula of energy, then you will say half mv square for kinetic energy, mgh for potential energy, right? So what is this? Even if you are having half here, which is a constant term, but you will analyze the units and the dimensions with this formula only. So if I ask you the dimension formula for energy, so mv square, we know mass is having m as dimension, and velocity or speed we have just found out here, lt minus 1. So that means it will become m l square t minus 2, right? So this will be the formula for energy, and it will be same for if you talk about mgh, and if you find out with the help of mgh, then also energy will be this only, ml square t minus 2. How? Let me show you. So for mass m, then g is acceleration due to gravity, and you know acceleration is what? Change in velocity upon time. So if change in velocity has the unit as meter per second, that means lt minus 1, and this is t here, so it will be lt minus 2, right? So here lt minus 2, and height is of course a length, a distance, so dimension will be l, so it will be m, there are two l's, so ml square and t minus 2, and you can see this is as same as this. So in this way you can find out the dimensions, and you have to exclude constant terms completely. Okay, another thing is that, let me show you with the help of example. Here, this is very famous question for CBSE. It is asked in the question paper. So this is van der Waals equation. These are not ideal guesses, these are real guesses, and they satisfy this form. So what is there is, if you talk about P is pressure here, A and B are van der Waals constants, V is volume, right? So what you need to find out is that, if I ask you find out the measurement or dimension of A, so what it would be? So second concept for dimension which you need to learn is that in dimensional formula we consider plus and minus as equal. So what I'm talking about is that, let's say you have V is equals to U plus AT. This is first equation of motion, you all are aware of it, right? So you want to check whether this is right or not dimensionally. So what you need to check, this is your left hand side, these are your right hand side, but let's say this is your right hand side first and this is your right hand side second. Why? Because plus and minus are considered or need to be considered as equal. So your left hand side dimensional formula for V will be LT minus 1, because displacement upon time. For U is initial velocity, but it doesn't matter what type of velocity it is. If it is velocity, be it final or initial, its dimensional formula will be same. And here for RHS2 you have AT, acceleration is LT minus 2, we just talk about it. And then this is T, time is T, so it will be LT minus 1. And this is how these three things are equal, and we can say that this formula is dimensionally correct. Okay, so similarly if you have to find out A here, so what you will do, you will put P equals A by V square, right? Because ultimately plus and minus are treated as equal. So A will be P V square. You know pressure is force upon area, and if you want to find out its dimension, so force is mass into acceleration, here area. So mass is m, acceleration is lt minus 2, and area is, if you talk about area of rectangle, then length into breadth, then this is also length, this is also length, so L square, right? Or you can consider this as well. So it will be 1 L will be cancelled with 1 L, so if you take it in numerator, L minus 1 T minus 2, right? So put it here. This will be ml minus 1 t minus 2, and volume. If you talk about cube, it is side cube. That means length cube. If you talk about cuboid, it is length into breadth into height. This is length, this is length, this is length. So you will take it as L cube, right? So what you've got, ml. So this is base same, power add in multiplication. 3 minus 1 is 2, t minus 2. So this will be the dimension of A. Similarly, you can find out the dimension of B as well, right? So V will be equal to B, and B will be, volume is L cube, right? So you can see that in this way we can find out any constant value. If, see, you can ask me that you have just told us that constant should not be considered, but you can see here A and B are van der Waals constant, which are given in the equation. These are not that type of constant which is arbitrary constant, right? They will be fixed according to the equational formula. So that's why we are finding out their dimensions. Okay, so I'm hoping that you have got this topic, and if so, then don't forget to like, share and subscribe my channel. Till my next video, take care of yourself. Bye bye.